Well, hello everybody. Sorry that you missed class today. I got a pretty tough lesson for you today. So I'll try to click right through this video, trying to show you some calculator stuff. There's a lot here, but it's really pretty cool how everything can come together. So things that you'll need to make sure that you have, you'll need that class notes, that day 4 class notes in front of you. The assignment, of course, will be that worksheet, not on OneNote, but that worksheet. You will also need a blank note card today in front of you. If you don't have that right now, you will need a blank piece of paper on there with lines on it. You'll see why the lines are going to be important here for a little bit. And then later on, we will transfer your Pascal's triangle to your note card. So those will be the items that you'll need. There will also be a time that you'll need to pause the video and write down your Pascal's triangle to 10 rows. You will understand what I mean here in just a heartbeat. So, if you would, I've already done some grunt work because I don't want this video to be an hour long or anything. So, look at your first 5 where it says expand. I want to point something out for you. I've already done some of the other just to speed things up, but look at x plus y to the 0. Remember guys, anything to the 0 power is always 1. So anything to the 0 is 1. What I'm focusing on is I want to focus on the coefficients today. If I come in here and look at x plus 1 to the first, I'm going to get x plus y. But what I want you to do is look at the coefficients as I go. The coefficient for this first one was just 1. Look at the coefficient for 1x plus 1y. Those coefficients each happen to be 1. You'll also see why I'm writing it like that. Now, come down to my third one, x plus y quantity squared. What I did is I wrote it out twice and I FOILed it out. So I got x squared plus 2xy plus y squared. Once again, look at those coefficients. The coefficient of the x squared is a 1. The coefficient of the middle term is a 2. The coefficient of the y squared term happened to be a 1. Now, here's where I really save this work, guys. I cubed x plus y, so I took the squared term from above and multiplied it by another x plus y. To do that, you did this in Algebra 2. I had to take this x and distribute it to each term. So I got x cubed plus 2x squared y plus xy squared. Then I started again and I distributed that y term. So I got x squared y plus 2xy squared plus y cubed. And then I simplified it. The key to simplifying is also put your terms in descending order for the variable that comes first in the alphabet. So in this case, an x. So when I simplified this, I got x cubed. I combined that and got 3x squared y. I combined that and got 3xy squared, and then that was a loner. Notice these terms again, the coefficients. The coefficient of the x cubed is a 1. The next coefficient was a 3. The next coefficient was a 3. The next coefficient was a 1. And then I really saved this time here. I took x squared plus 2xy plus y squared, which is x plus y squared, and I multiplied it by itself. As I did that, guys, I wound up having 9 terms before I simplified. This is what the simplified answer looked like. But what I really want you to notice there is look at the coefficients again. The coefficient of the x to the 4th was a 1. The next coefficient was a 4. And then there's a 6. And then there's a 4. And then there's a 1. What I'd like for you to do is focus on those coefficients for a second. I'm going to erase now this mess that I have in here so I can kind of talk to you a little bit about it. Blaise Pascal sat down for years and multiplied all these binomials out. He did it by hand. The cube, the 4th, the 5th, the 6th, the 7th, the 8th. But what he noticed is this. When he wrote the coefficients in the form of a triangle, there's a little pattern that developed. So picture this pattern. My first coefficient, which deals with my x plus y to the 0, was a 1. Notice when I took x plus y to the first, my coefficients was a 1 and a 1. Notice that when I went to a squared, my coefficients was a 1, 2, 1. He noticed this little pattern. There's going to be a 1 out here. To generate the next number, he went 1 plus 2, and notice this 3 showed up. Then he went 2 plus 1 is another 3, and then it ended with the 1. Look what happened after we did the cube, then we went on to the fourth. Started out here with the 1. 1 plus 3 was 4. 3 plus 3 was 6. 3 plus 1 was 4. And then there's a 1. Now, if you peek at your number 6 here for just a second, we're going to ask you to expand that. But here's what I'd like to do before I do that. I would like to help you create a note card that we're going to use on any test or quiz as a shortcut to expansions, and it'll help you as we start doing some probability items. So guys, what I'd hang with me on this video as you go, you need your note card or a blank piece of paper. Pause the video if I get too fast. I need you to start a note card. Start in the middle and write each one on a line. Off to the side, you're going to have row 0, row 1, 2, 3, 4. We're going to go all the way down to row 10. Now guys, to generate this note card, you're going to do this. You're going to write down a 1. So now for our fifth row, I'm going to have 1 plus 4 is 5. I'm going to have 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Boom. I now know when I get to that screen, when I do x plus y to the fifth, I know that these are the numbers in front. And then I will show you a cool shortcut to do that. So pause the video if you need. Off to the side, the far left of your note card, have this down as row 0. Have this down as row 1. That is row 2. That is row 3. There's row 4. And then you're going to generate a note card. I've cheated on my video, and I've already got row 5 coming up, row 6 coming up, row 7 coming up. So there happens to be what your row 5 will look like. But notice how I got that. I started with the 1. 1 plus 4 was 5. 4 plus 6 was 10. 6 plus 4 was 10. 4 plus 1 was 5, and then a 1. And then you're going to generate row 6. So this will now be your row 6 by the same method. Like I said, if I get too fast on you, pause the video. But it starts with the 1. 1 plus 5 was 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 was 15. 5 plus 1 was 6. And then a 1. So there's what your row 6 look like. Your row 7 will look like that. So I'll give you a second to write that down, or you could pause it. When you added in your row 8, it looked like that. There's what your 9th row should have looked like. We're going up to row 10. We won't do much over row 10. But what's cool about this, it goes on forever. So if you ever get bored, want to write it out to 50 rows or something. And then last but not least, guys, there's what your Pascal's triangle is going to look like. Off to the left, these will be your row. And we need to start with row 0. What that really means is any binomial to the 0 power. Any binomial to the first, to the second, to the third. So pause the video if you need. Make sure your triangle looks like my triangle, and then I'm going to move on. But pause it if you need to. So now, come in and let's look at your number 6. Watch how easy this becomes. Compare the coefficients to the numbers that appear in Pascal's triangle. Use this to expand the following. X plus y to the 5th. There is no way I want to expand that the long way. I'm going to go to your note card, look up row 5. And you'll notice row 5 has these coefficients: 1, 5, 10. Well, my pen's not wanting to work now all of a sudden. There it goes. And then another 10. So I should have 1, 5, 10, 10, 5, 1. Now, watch how easy it is to expand this. This is the cool part. Since I'm to the 5th power, my first coefficient is going to contain a 1. I'm going to have whatever this term is to the 5th power. So I'm going to have my first term is going to be x to the 5th. My x's will decrease by 1 over and over and over. My y terms will start increasing by 1. So here it goes. I've got x to the 5th plus. My next term is a 5. My x term is going to go down by 1. My y term increases by 1. My next term is a 10. My x is going to drop down to a 3. My y is going to increase to a 2. My next term will contain a 10. My x term will be a squared. My y term will be a cubed. My next term will be a 5. My x will be to the 1st. My y will be to the 4th. Plus y to the 5th. Now I want to point some things out, because a lot of times on Pascal's triangle it looks confusing right off the bat. I want you to notice the first term, which happened to be an x. Notice this first term had a 5th, and then a 4th, and then a 3rd, a squared, a 1, and then a 0. Notice the second term started at a power of a 0, and then it increased 1, 2, 3, 4, 5. Notice that I was to the 5th power. Notice that all of my powers add up to be a 5. 5 and 0 make 5. 4 and 1 make 5. 3 and 2, 2 and 3, 1 and 4, 5. So notice all those things. Okay? So on to your number 6. I've got v plus 2 to the 3rd. Look at your Pascal's triangle, row 3. And then those coefficients happen to be a 1, a 3, a 3, and a 1. So here goes. When I start expanding this, my first coefficient's a 1, which I'm not even going to write down. My v term will be to the 3rd power, plus. My next coefficient's going to have a 3 in there. I'm going to have v squared times a 2 to the 1st, plus. My next term is going to have a 3 as a coefficient. My v term is going to decrease by 1, but my next term will increase by 1. So my v's went 3rd squared to the 1st. My 2's went none, 1, 2. Then my last term, my coefficient is a 1. I will not have any v's in there, but I will have a 2 3 times. Now let's simplify this real fast. V to the 3rd is v to the 3rd, plus 3 times 2 becomes 6 v squared, plus 2 squared is 4, 4 times 3 is 12 v, plus 2 cubed is 8. So guys, that's how it goes. Think of these as terms, and we'll put them in parentheses as needed, and we'll go from there. Come over to your number 8 if you would. I'm going to do number 8 with you. We will not do number 9 because these take a little bit of time. But once again, you will look at your Pascal's triangle note card. You will look at row 5, and you will see that those coefficients go 1, 5, 10, 10, 5, 1. And then here goes your pattern. My first term is going to have a 1, and then I'm going to have a 1 to the 5th power. So I had a coefficient of a 1, that guy right there. I have this term, which happens to be a 1, to the 5th power, plus. My next term has a 5 as a coefficient. I'm going to have a 1 4 times, and I'm going to have a negative 2q 1 time. And then my next term is going to have a 10 in there. I'm going to have a 1 3 times. I'm going to have a negative 2q twice. My next term, so I've used that guy. My next term looks like a 10. I'm going to have a 1 in there twice, but I'm going to have a negative 2q 3 times. And then I'm almost out of room, but I'm going to have a 5. I'm going to have a 1 in there 4 times, and I'm going to have a negative 2q in there. Oops, my 1 in there, my computer jumped around. My 1 in there is going to be 1 time. My negative 2q is going to be in there 4 times. And then my last term will have a 1 as a coefficient. I'll have no 1s in there, but I will have negative 2q in there 5 times. So now let's go through and simplify this. My first term is going to be 1 to the 5th, which happens to be 1. Now let's look at your next term. I'm going to have 5 times 1 to the 4th times negative 2q. So it looks like that's going to be negative 10q plus. Now let's go to the third term. I'm going to have a 10 times 1 and negative 2 squared. So negative 2 squared is 4 times 10. So I'm going to have 40q squared. Now let's go to our next term. I'm going to have a 10 times 1 times negative 2 to the third. Negative 2 cubed is negative 8 times 10. So I'm going to have negative 80q to the third plus. Now my last term, or next to last term, I'm going to have a 5 times negative 2 to the fourth. Well, negative 2 to the fourth is 16 times 5. So I'm going to have positive 80q to the fourth q to the fourth, I said. And then how about my last term? Negative 2 to the fifth, negative 32q to the fifth. You could rewrite that and put that in descending order if you like. We won't worry about it here because they started with the 1, so we'll just roll with that. But guys, that's Pascal's triangle. We're going to keep using it, so keep that note card in front of you. But for video's sake, I went ahead and bypassed number 9 so I could make a little bit of time here. So if you would, come to your number 10. Once again, keep that note card right in front of you. My number 10 says this: what's the coefficient of x squared y cubed in the expansion of 2x plus 5y to the fifth? Well, here's what you need to do. Go look at row 5 on your Pascal's triangle. Those coefficients, once again, 1, 5, 10, 10, 5, and 1. Now, look at what we got going so far. This 1 represents x to the 5th. See where I got that? This represents x to the 4th. This will represent the coefficient with the x cubed. This must represent the coefficient with the x squared term. So something I know so far, there's a 10 in my coefficient so far. I've got that from Pascal's triangle. I'm also going to have 2x, that quantity, squared, times 5y to the third. Now, we're worried about the coefficient. So grab your calculator or your brain. The coefficient then is going to become 10 times 2 squared is 4. 5 cubed is 125. If I go 10 times 4 times 125, that coefficient's going to be 5,000. So guys, what I did is I listed row 5, decided that there's a 10 out front, and then I had to take in consideration the terms. I was going to have a 2x squared, and then the second term, that 5y cubed. And they just wanted the coefficient, so we just wanted the number. So look at your number 11. It says, what's the coefficient of v squared w to the 5th in the expansion of 2v minus 3w? So look at your Pascal's note card again. Go down to row 7. So I've got a 1, 7, 21, 35, 35, 21, 7, and 1. Now do a little countdown. This term represents v to the 7th, v to the 6th, v to the 5th, v to the 4th, v cubed. Here's finally my v squared. So I know there's a 21 in there. I'm also going to have a 2v to the 2nd, because that's what the problem says, times a negative 3w to the 5th. Now, we're just worried about the coefficient. So I'm going to take my 21 times 2 squared times negative 3 to the 5th. Run that through your calculator. You're going to see that the coefficient for that one is going to be negative 20,412. So there's what we got going so far. Now, I'm going to switch gears a little bit about you. The cool thing with Pascal's triangle, there's going to be two cool things. One, your calculator can do some neat stuff for you. And then it's used in Vegas a lot. It'll give you the total number of outcomes. What I'm going to show you coming up is the binomial probabilities. It's used anytime there's one or two choices, like flipping a coin, the birth of a baby being boy or girl, a true or false because there's just two choices, answering a test question right or wrong, living, dying, a success or a failure. That's called a binomial because there's just two choices. So if you would come over to your number 12, it says a coin is flipped 5 times. How many total outcomes are there? Well, to get that, I would have to do this. I'm going to flip this coin 5 times. I've got 2 choices for the first flip, 2 for the second flip, 2 for the third, fourth, and fifth. 2 times 2 times 2 times 2 times 2 is 32. So I know there's 32 different outcomes. We're not going to list them all either. Now, go to row 5 on your Pascal's note card and add those coefficients together. So guys, if you go to row 5, you get these coefficients again. 1, 5, 10, 10, 5, 1. If you add those together, I'm up to 10, 20, 32. So one cool thing about Pascal's triangle, it tells you the number of outcomes if you add up the total number in the row. What does this represent? The total number of outcomes. Now, it does some more neat stuff for you too. Use this expansion of h plus t, heads plus tails, to the 5th to determine the probability of at least 2 heads. So guys, let me make sure you fully understand what this is saying. And good old thing cuts out just a little bit. 5 and 1. There, we're back. Here's what this says. There's one way to get 5 heads. It says that there's 5 ways to get 4 heads. If you think about it, head, 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 tail, head, head, tails, head, head. There's 10 ways to get 3 heads, there's 10 ways to get 2 heads, there's 5 ways to get 1 head, and there's 1 way to get 0 heads. So now let's answer this. The probability that at least 2 heads show up, I need to add up this guy, this guy, this guy, and that guy. Because it says at least 2 heads. So 2 heads, 3 heads, 4 heads, or 5 heads. This tells me that there's 26 ways out of the 32 for that to happen. My ending answer, 13/16. Now, I'm having to write this because I don't have the note card right in front of me. You do. You will just go say to your head, okay, 5 heads, 4 heads, 3 heads, 2 heads. Add those up. Bam, you got it. Okay. Here comes your number 13. A coin is flipped 6 times. How many of the possible outcomes have at least 3 heads? Here's all you're going to do. You're going to look at row 6 on your note card, which is 1, 6, 15, 20. 15, 6, and 1. You'll say to yourself, there's 1 way to get 6 heads. There's 6 ways to get 5 heads, 15 ways to get 4, 20 ways to get 3 heads, 15 ways to get 2 heads, 6 ways to get 1 head, and 1 way to get 0 heads. Okay? Now, let's go and answer the question. How many possible outcomes have at least 3 heads? Well, you want to add up those right there and get 35, 41, 42. So there's 42 that have at least 3 heads. The probability, capital P for probability, of at least 3 heads, there's 42 ways out of, add those all up, and you're going to get 64. Once I reduce that, 21 30-seconds. Okay. It says how many outcomes have exactly 3 heads? Well, I'm going to look right there. There's 20 for that answer. How many outcomes have exactly 3 heads? So the probability of exactly 3 heads is 20 out of the 64, which would be 5/16. But that's how we're going to use the Pascal's triangle. Here goes our number 14. Suppose that a probability for a certain cancer to remain in remission for at least 1 year after chemotherapy is 0.7 for all patients with that type of cancer. It says find the probability that exactly 2 of the 4 patients currently being monitored can keep the cancer in remission for at least 1 year. So guys, I'm going to go to, we're talking about 6 total, we're talking about 4 people. So go to row 4 on your note card. The coefficients happen to be 1, 4, 6, 4, 1. This would mean there's 1 way for all of them, 4 ways for 3 of them, 6 ways for 2, 4 ways for 1, 1 way for none. So we want to look at exactly 2. So this would be all 4 or 3, exactly 2. So I'm going to have a 6 in my coefficient. The success rate here was a 0.7, so I'm going to have a 0.7 squared times the leftover, the 0.3 squared. So here's what I did. I had to figure out how many ways there was to do it, and we said exactly 2. So 2 of them stayed in remission, 2 of them did not. You'll grab your calculator and you'll run this through. And if you do that, you're going to get 0.2646. Now guys, here I'm also going to show you your calculator can do this for you. So if you would, have your calculator out. You might have to pause the video and write these steps down. But this is called a binomial distribution. So if you would, grab your calculator. This is really cool. Your calculator does all this work for you. To get there, you're going to go second distribution, so second bars. And write these steps down on the back of your note card if you'd like to. But to get there, you're going to go second bars. And on my calculator, it's a 0. I've seen it on some calculators On this calculator, it's an A. On my other calculator, it's a 0. But you want the one that says binomial PDF. Binomial PDF. So on this calculator, it's an A. So hit enter on that. Now here's how you do this. You tell the calculator that you're looking at 4 people. So type in a 4 and then a comma. And then you type in your main probability. It was 0.7 for somebody to stay in remission. And then in the next one, you want to tell the calculator how many you want you're exploring. So I'm going to type a 2. Now here's what this is asking your calculator to do. It's asking your calculator to do that little formula that we just had. I'm dealing with 4 patients. A success rate is 0.7. We're looking at exactly 2 of them stand in that. Once you hit enter, guys, your calculator will go get you this answer. So if you need to write those steps down, do that real fast. Remember to get there, you go second bars, and on this calculator it's a Z, it's an A. Make sure you write down whatever it is on your calculator. So this one's A, and then in the first blank, remember, so it's going to look like this, binomial distribution. In the first blank, it's the number that you're dealing with. In the next blank, it's your successful probability. It's the probability you're given. In your next blank is the number that you're trying to explore. So there's some calculator work for you. I'm going to show you what it looks like here in a second otherwise too. Now, come back to your part B real fast. It says find the probability that 2 or 3 patients. There's 2 ways to do this, and I'm going to show you the calculator way. I could use this formula. That would be for 2. I'd have to go in and add in the number for 3. But let's let your calculator do this. I'm going to write out this command, and I'll show you how to get there. I'm going to sum up the binomial distribution. So write this down if you would. And let me get rid of these little tick marks here. And it's going to look like this. There's a parenthesis. I'm dealing with 4 people. My success rate is 0.7, a comma, and then it has to be typed in this way. I need to go get that cool parenthesis here, or that brace, and I need to tell it I'm looking at 2 people or 3 people. There's what it looks like. And then technically there would be a parenthesis, but okay. So now guys, in terms of the calculator, here's what it looks like. I'm going to go second stat over to math down to sum. Second stat math down to sum. Now I need the binomial distribution. So second vars down to my A. And then I need to tell it I'm dealing with 4 people, comma. The success rate is 0.7, comma. And I'm going to go second brace. So second brace, 2, comma, 3. And I'm going to close that off. Now guys, the reason I had to put the sum in here, because there's more than one, I'm having to add them up. On the first one, there wasn't. Now your calculator will go get that for you. So 0.6762. I'm also going to go math, enter, enter, and see if it gives me a nice fraction. So either answer 3381/5000, or since it was a nice decimal, 0.6762. So I've got a couple more of those coming your way, just so that you could see them. I'll write them out, and then we can go get them. So come over to your number 15, if you would. A quiz has 8 multiple choice questions, each with 4 alternatives. So pause for 1 second. There's an A, B, C, D. There's 4 alternatives. The chance that you get it correct is 1 in 4 or 0.25. If you guessed, there's a 1 in 4 chance that you're going to get it right, or 0.25. That's really important here in a second. Another important thing is I know that there's 8 questions. If a student guesses randomly on every question, what's the probability of getting 5 correct? This is a binomial distribution because they either get it right or they get it wrong. So it's going to look like this. Binomial PDF, 8 questions, comma, a success is 0.25. We're wondering on how to get 5 right. So there's what you're going to type in your calculator. I do not need the word sum because we're just focusing on 1. So guys, in terms of my calculator, second bars, in my chance, I'm going to go down to number 8, or A, I hope. So there it is. I'm going to tell it 8, comma, 0.25, comma, exactly 5. My calculator gives me that. I'm going to see math, enter, enter. So either answer 189 over 189 over 8192 or about 0.023. Now, here comes my part B then. It says, what's the probability of getting 5 or more? Whenever we're dealing with more, guys, it's going to look like this. Sum, binomial PDF. There's 8 questions. A success is 0.25, comma, brace, and it says 5 or more. So then I could get 5, 6, 7, or 8. So in the calculator, it's going to look like this. I'll clear that out for you guys. I'm going to go second stat, so I could go get the word sum. If you forget the word sum, it'll list it out for you. You'll have to add them up by hand. Second distribution, down to A. Sorry if the little ticks bother you on the video. There's 8 questions, comma, a success is 0.25, comma, since there's more than one, the brace, and I can get 5, comma, 6, 7, or 8. Close your brace off. And that's what you should get. 0.0273, so I'm going to say approximately 0.0273. I don't know if I could have hit math enter enter and got a nice fraction or not. Not in this case. Okay, so guys, that's what it's going to look like. I've got 2 more down there, number 17 and number 8. I'll show you the setup of them really fast, and then I'll be all done with the video. Number 16, I got a little typo. I need to put a number of. So let's skip number 16. Let me show you what number 17 should look like. In 17 and 18, use the probability of a heart pacemaker working flawlessly for 1 year to be 0.92. And that the pacemaker is given to 6 patients. What's the probability that 5 of the 6 pacemakers will function flawlessly for a year? So it either does or it doesn't. Makes it a binomial probability. I don't need the word sum because I'm just worried about 1. So 6 that we gave it to. A success is 0.92, and we're looking at exactly 5. So once again, hopefully you got these strokes down. Second bars down to the A in my calculator. There's 6 of them, comma. 0.92 is a success, comma. We're looking at exactly 5. So there's where I got my 0.3164. And good old inner right cuts out a little bit on me. So there's that. Now the next one, what's the probability that at least 3? Since you're dealing with more than one, it looks like this. And we will ask you to write this out so we know what you did. So sum binomial probability 6.92, comma, brace, and it says at least 3. So I need to go brace 3, comma, 4, comma, 5, comma, 6. Okay. And you can run that through, guys. You're going to get about 0.9995. Okay. So guys, that is our Pascal's triangle day. It's a long day, but it kind of works out pretty nice. Next time we're going to give you time to work on this. So the assignment's kind of long and tedious in places, but you're going to have some time to work on it. So the assignment is your day 4 assignment. Come in and let us know if you have any questions. Good luck.